So in order to solve for x in number 1, we need to first isolate the variable. So here I see I need to get rid of the constant, which is 1. So I'm going to do the opposite of adding 1. I'm going to subtract 1 from both sides. So I know that 3x equals 9. And in order to get x alone, I need to divide both sides by 3. And I know that x equals 3. Again, for number 2, in order to get rid of that constant of negative 3, I can do the opposite of adding negative 3. So I'm going to subtract negative 3, or subtracting a negative is the same as adding a positive. So I'm going to add 3 to both sides. So now that 8n equals negative 2. And then I can divide both sides by 8. And n will equal negative 1/4. Alright, for number 3, I need to get rid of the constant, so I'm going to add 6 to both sides. So I know that 4h equals 28. And then in order to get h alone, I divide by 4. And h is equal to 7, because 7 times 4 is 28. Alright, for number 4, when I get rid of my constant, I need to subtract 1 from both sides. And I know that negative 8s is equal to 32. When I divide both sides by negative 8, I know that s is equal to negative 4. Once again, I always start by getting rid of the constant, so I'm going to add 4 to both sides. I know that negative 4w is equal to 12. And I divide both sides by negative 4. So I know that w is equal to negative 3. So for number 6, in order to get b alone, I need to get rid of the constant on both sides, so I'm going to subtract 5. And then I know that 1/7 b is equal to negative 7. Then I need to divide both sides by 1/7. So I know I'll have b alone over here. And then I'm going to write this off to the side, negative 7 over 1. I'm going to switch flip. So I know that this will be equal to negative 7 times 7, which is negative 49. For number 7, a bar diagram is just another way for you to solve problems like this, and a little bit more the concrete representation so that you can understand them better. So there's a really good example on page 472, the little green post-it note there, that can show you how to do this. But I know that my entire bar is going to stand for $189 because it says that Cristiano is saving money to buy a bike that costs $189 total. So I know that this total bar stands for $189. So the next piece of information I know for my problem is that he has $99 saved so far. Whoop. So I know that 99 is a little bit more than half of 189. So we'll just rough estimate it, put it there, and say that this part of the strip is $99. So finally, the question asks, in how many weeks will he have enough money to buy the bike, knowing that he saves $10 each week? So I know he already has $99 here. This next part of the strip is going to stand for the money that he needs to save. So he is going to save $10 each week, or 10W. So now when I put this into an equation, I can write that $189 is equal to $99, which is like our constant in the equations above, plus the $10 each week. So when I solve this equation, I can again get rid of my constant, so I can take 189, subtract 99. We'll subtract that from both sides. That cancels that out, and on this side I'll have 90 is equal to 10W. And again, I'm just going to divide both sides by 10. And I know that W is equal to 9. So my answer to that question would be, it would take him 9 weeks to save up enough money to buy the bike. Alright, and for number 8, I need to get rid of my constant again. So I'm going to add 3.1 to both sides. And I know that 2R is equal to 4.8. Divide both sides by 2. And R is equal to 2.4. For number 9, I need to get rid of my constant from both sides. So I know that 4t equals 9. And when I divide both sides by 4, I know that t is equal to 2, and 1/4, or 2.25 in decimal form. Alright, number 10, coming at you in a new color. Brace yourselves. We're going to add 5.5 to both sides. So we'll cancel out the constant, and I know that 8m is equal to 15.6. I'm going to divide both sides by 8. And m is equal to 1.95. Alrighty, home stretch, page 475. First we need to get rid of the constant on number 17. So I know that 6m is equal to negative 24. When I divide both sides by 6, m is going to be equal to negative 4. Alright, for number 18, I need to do the opposite of adding 5, so I'm going to subtract 5 from both sides. And I know that 4d is equal to 32. When I divide both sides by 4 to isolate the variable or get d alone, I know that d is equal to 8. Number 19, I'm going to do the opposite of adding 3, so I'm going to subtract 3 from both sides. Negative 7y will be equal to negative 28. And I divide each side by negative 7. I know that my answer will be 4, because 4 times negative 7 is negative 28. Alright, for negative 20, I first need to get rid of my constant again. So I'll subtract 25 from both sides. I know that 11/12 b is equal to 47 minus 25, or 22. And my next step is to not only acknowledge how sad that first 2 looks, because that is rough, but I need to get b alone, so I need to divide each side by 11/12. So now I know that b is equal to, and I'll do this one over on the side, 22 over 1, switch, flip, so I'll switch to multiplication and flip my second fraction. Then I know that 22 times 12 is 264, 1 times 11 is 11, and 264 divided by 11 is 24. So that's my final answer for B. For number 21, we're going to bring her down here. I need to get rid of my constant, so I'm going to subtract 15 from both sides. And I know that negative 1/2 b is equal to negative 18. Then I can subtract each side by negative 1/2. So I know that b is equal to negative 18, over 1, keep, switch, flip. So negative 18 times negative 2 is 36 over 1. So I know that b is equal to 36. Finally, we have one more bar diagram to make. So after reading this problem, I know that I have $12.50 total. So I know that this whole bar is equal to $12.50. Then I keep reading. It says it costs $7.50 to enter a petting zoo. So I know this part will be $7.50. That's going to be my constant. And then each cup of food to feed the animals is $2.50. So let's see. We can just say $2.50 x. So in this problem, x stands for the number of cups of food you can buy, which each costs $2.50. So that's where that came from. So now I can write my equation out. I know that $12.50 is equal to, remember, $7.50 is my constant. $7.50 plus $2.50 for every cup of food. So $2.50 times x. So finally, I can solve for x the same way I've been solving the other ones. So I'm going to get rid of my constant. So I'll subtract $7.50. So on this side, all I'm going to have is $2.50 x, or times x, is equal to $5. Then I can divide each side by $2.50. So I know that x is equal to 2. So in this problem, it's saying that I can buy 2 cups of animal feed, which will probably all get eaten by just like one llama, so that would be pretty lame.